Okay, the very first thing, easy. Let me see where I go. Okay, I need your check-in a little bit, so get relaxed and do the check-in. How do you feel? Okay. Okay, come on. If you are on single screen, yeah, I think it's easy to use mobile phone as well. No need to use on the laptop because then otherwise you may not see the other things, the share screen. Anyway, okay, we have 35. I need more. You need to complete this and tell me a little bit. Okay. So at least you are mostly okay, a good sign. You're excited, you're energetic, so that is good. Some of you need coffee. Okay, you feel sleepy and tired. Don't get nervous. Okay, I'm not gonna do anything that is so harmful. Okay, and confused. Okay, we are going to play some games and get relaxed. Okay, nothing to worry. Okay, and okay, I think we will do a quiz now. So be ready. I need to move my screen a little bit. Sorry. Okay, yes. Okay, be ready. It's easy stuff. Actually, I just make it very. Okay, now we have this question. Pay attention. Okay. And think of the answer. You need to type the answer later. But get your answer because you have very less time to do. And only the capital character to fill in. Okay, I'm going. Okay, I think you now got your avatar and your name or your stuff. Okay, who are some lovely cat, dog, penguin, frog, and so on. Okay. We do some. Sorry. You have to be fast. Am I fast? Are you fast enough? Okay. Those the four. Maybe I skipped the first question somehow. Let me look later on. Okay. So there are the four phases, right? That we discussed: the interview, data collection, and so on. Logical requirement collection, analysis, conceptual design, physical design, logical design. Actually, they are the order, right? And for this phase, database designer, interview, prospective, database user, to understand and document data requirement is the phase that belongs to, is the activity for requirement collection and analysis. I think most of you could do it, but just the very confusion stage for the very first question. Okay, then we move next. I think let's try. Somehow I skipped the first slide somehow. Maybe I was too fast. So those who answer correct and fast, you get the higher score. So far, Ramesh, you there, right? Okay, you're in the front, fastest, okay, to answer correctly. And I think everyone who answered correctly, you got score, but you just need to be fast enough to get score better than your friends. Okay, that's just a warm up. Okay, mostly the other things are the same. That is, you will be given questions and then you need to answer fast and correct. Wrong answer means 0. Correct answer but slow, you get something. Okay, so don't just rush for the answer. Yeah, I think I skipped question 1 somehow. Sorry, I was too fast to let you fill in the answer. Okay, question 3. It's still about database design. No, okay, I was too fast. What happened? The result of this phase, what phase is this? Is a high-level data model describing entity types, relationships, and constraints. The high-level data model, yes, it is conceptual design. First, you do the requirement collection to understand the data by interviewing with the users, right? To understand what kind of data they want. Then you really need to do the modeling in order to make a high-level model, okay? And it may include the data entity, may include relationships among them, may include constraints, attributes, and so on. And that is part of conceptual design phase, okay? And then what is next? Then let's look at the leader, okay? Okay, we got new leader board. I mean, the leaderboard is updated. We got new top players. Okay, let's go next. For question 4, I will go back to question 1 later on. I think we skipped question 1 somehow, and I think I can still go back. So which phase it is? For the 4th phase, which results in database schema in the implementation model of selected database management system. Okay. It's the phase that is called logical design. Once you have done the conceptual design, we need to move on for the logical design in order to make specific database schema according to what you choose. I mean, the database model that you choose, such as if we choose to use relational data system, data model, data management system, then you do the logical design based on the relational schema, relational theory. Okay, so the first 3 top rank, who are you? Let's see. Oh, wow. Now, who is Mr. Now or Miss Now?
I am.
Who are you? Sorry?
I am, teacher.
Oh, okay. That is you. It's a red. Congratulations. Now you're on the top. Anne, where are you? Are you in the room? Okay, you are An. Okay, congratulations to Anton Son. You there? Okay. I and Pratyush and still. Oh, okay. Congratulations for Pratyush for this one. You're the fastest somehow. Okay. Then the very next question. Okay. I think that is easy. So this phase involves defining internal storage structure, file organization, indexes, access path of the database. So which one should it be? Okay. Yes. Physical database design. This is the last phase of database design that we that involves this thing. But hey, I have got confused why there's still some answers for the phase of requirement collection and analysis, and also some answer for the conceptual design. Okay, so please be clear about these steps of doing the 4 database design phases. Okay, I think I will explain in more detail later on, but let's quickly have a look here. Okay, good. All right, then here I would just need to emphasize on this picture, which is one of the slides that we have in the relational model, ER model design, and so on. So we follow the data abstraction. We follow the architecture of designing database model in the way that actually we can divide or we can classify the data model in terms of the level of the independence of the data model according to hardware, software, and also the perspective of the users. Okay, if actually for users perspective, user have needs for data and view to access and use the data. So different users may have different view and needs for the data that you may need to understand what kind of view you want to design the database for different types of user. And we move on to the conceptual schema or the conceptual design in a way that this is very hardware independent and software independent. You just need to model and describe the data in the manner that you don't need to worry what kind of database technology you are going to use, whether you use relational model, whether you will use NoSQL model, and so on. That is fine. It's just about understanding the data. Okay, so it is part of what we call conceptual model. And once actually we do further refining, okay, we need to, of course, transform from the conceptual model, conceptual schema, conceptual model, they are the same, into logical model. Or actually, sometimes it is called internal model that is specific to some of the database technology that you want to choose. Okay, so in that case, that is why if you choose to use relational model like modeling data using table structures, key, foreign key, and so on, in the way that we discussed last time, right? Then you design relational schema for your database. Okay, and that is called logical schema or internal schema, and so on. And later on, and in the last phase, it is physical model, which means that you describe the access structure, the index, and so far and so forth in order to optimize the usage of your system according to the database system, database tool, database engine you are using. Okay, and that is how all these 4 phases relate with each other. And in summary, the external model are for the end user's view. They are independent of hardware and software. Conceptual model is a global view of the data in which, of course, it is hardware and software independent. You can freely choose anything. It's just capture data requirements, Logical view is very specific to data model you use, such as if you want to use relational model, as I said, we want to use document model. In that case, logical schema will be very different, but still conceptual schema remain the same. Logical schema will be tailored, customized, and model according to the data store database technology you aim to use, database model you aim to use. So it is still hardware independent, but software dependent. Depend on certain kind of software or database technology. Okay. When it comes to physical model, we define and focus on storage and access methods in order to make it very performance oriented, right? Fastest way to return and retrieve the data, operate your data, and so on. So in this last phase, it is neither hardware or software independent. Okay, it's very specific to the hardware you use, very specific to the software or the DBMS you choose. So if we consider according to the level of abstraction, we can see that the very highest abstract level is when it is on the very top, the external view. The very lowest abstraction is when it is on the physical view, physical model. Okay. And this next slide actually show us, how all these phases connect into the flow and picture, right? That is starting from a mini world of your data requirements. We perform requirement collection and analysis. We perform conceptual design, perform logical design, physical design, and each of the phase results in certain output. Okay. Okay, then I think we have a few questions to go. Just 3 more, 6, 7, and 8. So we continue. So now we are talking about ER model. So ER model is the result of which phase? Those 4 phases, which one produce ER model as the output? Aha, okay, very good. Still most of you, but half of you is half. Half correct, half incorrect. ER model, entity relationship model, is what we will learn in more detail today. Okay, is the result of conceptual modeling phase. That means it's still independent of any hardware and any software. So it is just a modeling language that you can use for modeling the data requirement. So basically the purpose, the goal of ER is to model and to let the designer, the user understand data requirements and data relationships and characteristics of the data you are focusing on. Okay. All right. So, wow, with half like this, I'm not sure what will be the change. Hey, wow. Okay. Congratulations to now Nitin, Vidat, Viplak, and so on. Okay. Anyway, you're on the leaderboard. Okay, next. 2 more questions and then we go to the serious stuff. Okay, question 7. Then if we talk about relational model, data model, or SQL model, it's supposed to be the result of which phase? For sure, I think you can remove some choice, right? Should not be conceptual design anymore, huh? Okay, still some of you answer conceptual design. No, conceptual design results in ER model, right? Once you move on from ER model, you can go further to the logical design phase and then choose the right database technology, in which if you choose relational database model as the technology, then you can have the relational schema as a result of logical design phase. Okay. So, and then, okay, who's next? Here. Okay. Good job to everyone. Even some of you may not be on the leaderboard, but this is just for fun, okay? Nothing too serious. Okay, the very last question, then we are done. So hope you get the last one. If we talk about ER model, it comprises of all these elements except one. Which one is not the modeling element, the main modeling element of ER model? Hey, how come still have some wrong answers? Okay, ER stand for entity relationship model. Those who answer wrong, I need to recheck with you whether you have done the reading before coming to the class or not. Okay, main modeling element of ER model comprise entity relationship and attributes, but not the now value. These are this now values is there, of course, but not the modeling element. Okay, anyway, that's all for this quiz, and then we go into the ER modeling together. Okay. I may need to capture this result a little bit. Now, congratulations. Can you stand up and get an applause? Okay, and Miao, Ramesh, and Sagan, and actually everyone. So big applause to yourself, okay? And Pradyush, you always make the very fast test. Correct answer. When it is the correct one, you could do it very fast. Oh, okay. All right, what else that I can go now? I think that's the end of the quiz. Okay, so I will need to switch back to the topic that we focused today. Okay. Okay, I stop this sharing. Okay, hope you get some good mood to study now the ER model and the database design. What's wrong with it? Okay, that is our main plan for today. This topic of ER modeling. Maybe I can share this. Okay, I skipped to the parts that we were there. All the details are there. So we were talking, I think, up to this. So the screen is shared. Okay. So back to ER, it stands for entity relationship. So definitely the main elements for ER is comprise entity, relationships, and attributes. Okay, and then I go very quick. Okay, entity is used to represent a class or object of interest that you want to model in your database system. And it, for example, it can be a person, a place, a thing, or anything, a product, bank account, a course, an air ticket, a flight, and so on, or even a patient health record. And actually entities usually have attributes to describe the details of the entity, describe the data characteristics of entity. So attributes in attributes of entity, right, is a property that describes a particular entity. And some attribute, of course, could be a key or identifier. That is, it can uniquely distinguish an entity from another. In that case, it could be the key attribute. And there are several types of attributes. One thing to make sure that you don't get confused is that don't mix up, okay, ER model with relational model. There are different concepts. There are different modeling concepts, but they are very related, very close to each other. And we can transform or convert one model to another. Okay. One thing to emphasize is that ER model, ER model is a result of conceptual design, right? Entity relational schema is a result from logical design. But there are many of the concepts that have some similarity or even the same. Okay. When we talk about attributes, in ER, attributes describe entities. But of course, we will see that from ER, we can convert, or how do we convert ER model into relational tables and attributes and key and so on. Okay. So types of attributes, attribute can be composite versus simple, can have single value versus multi-value. I think we discussed this already, right? Can have certain store of derived values, can or may contain null values, and all these, many of these are complex attributes, such as when they are composite, when they are multi-value, they are complex attributes. I would like to emphasize a little bit more that store value versus derived values would be the case that you can compute an attribute from another attribute that is derived value. Otherwise, it's just simply store value, such as your name. We cannot derive your name from something else, right? It's just the name that is given, it has to be stored. But your age can be derived, for example, from the date of birth. Your CGPA perhaps can be derived by calculating the average GPA of the entire study, right? And many more. So you need to be able to identify which one is store attributes, store value attributes, which one are derived value attributes. Okay. And these show you, I would like to go and in a summary way with example, that is notation in ER model is the graphical notation. ER models provide us graphical notation. So that is why sometimes many people call not ER model, but ER diagram. So it's a graphical diagram that allow us to draw to draw and to describe data, to show the relationships among data, the characteristics of the data you are modeling, and so on. Okay, so it's pretty good diagram for communication and understanding about data. So when we talk about graphical diagram, then of course you need to have certain standard notation to understand the standard meaning. Entity is drawn with rectangle. Attributes that belong to entity are represented as oval, okay, or bubble. And then you have a connecting line to define that which attributes describe which entity. For example, here we have entity employee, and you can see here that we have attribute birth date. Okay, I start from here. We have attribute social security number, name, birth date, department, salary, sex, supervisor, address, and so on. Okay, these are attributes describing such entity employee. And what else? Okay, when we talk about composite means an attribute may compose of sub-attributes, right? So in this graphical notation, you can see that an attribute name composed of sub-attributes, first name, middle init, middle name or initial or middle, right? Okay, and then last name. So this is notation for composite. How about multi-value? Notation for multi-values would be a double oval like this. Also here. So in this example, department entity has many locations. That is why it has double oval with multi-value. So it means that one department may have multiple locations, but all the other example of attributes, they are just single value. Okay. And one small thing, ER model. As I said, it is a graphical notation. With standard meaning, of course. So that means when you see this notation, you can actually understand the meaning according to the notation, right? For example, this means entity. And of course, you need to write entity name here inside. This means attribute. And of course, you need to define or write down the attribute name as well. And there are multiple notation available. I mean, multiple standard notations that people, designer have been used. The one that we have seen in the example and that we will use mostly for this course as the main one is called Shen notation. But there are a few others, such as Profoot notation. And many more. A few more, not many actually. So you need to choose and stick to one, okay? Don't mix up. And actually every of the notation or graphical symbol carries certain meaning, as I said. So you need to make sure that you follow one notation, okay? And as I said, we will basically use Shen notation. I think in SQL MySQL Workbench, it basically employs Crowfoot notation. It is a bit more compact. Okay, but I found Shen notation is clear for understand clearly. It's much clear to explain and to learn the notation. But once you are familiar with the ER concept, I can actually use any notations easily. Okay. All right, that's the things to remind. And then, okay, back to here. So these are Shen notation. And then these are example of some of the entities plus attributes. Okay. Let me see here. let me explain here. I skipped here. So in these slides that we will discuss, we will show how can we make ER model to model database of a company, a particular company that may maintain data about employees, departments, projects, as well as details related to position, managers of employees, and so on. And it also keep track of the dependents of each employee. So actually, when you are going to design a database, we are in the course of data modeling and management, right? We want to model first, model the data in order to properly manage the data, right? For your organization, for a company, for any kind of usage purpose. So the very first thing is to model your data. You need to know what to model. So that means we start from this phase, right? Remember? You need to understand the requirements of your data requirements. By going through perhaps requirements analysis, requirement understanding, and so on. And now we are focusing on only requirement related to data. So I will say data requirement. In which you need to be able to answer what data you want to model in your database, right? You need to be able to understand perhaps related to the model characteristic. You need to know what to model, what operations later on you want to do with the data. You want to understand the relationship among the data, and also the constraint. Maybe I move this. Okay, I think this is basically what you have to answer before. Okay. What kind of data you want to model? In this case, if we follow entity relationship concept, you need to be able to define, right? What entities, what attributes of the entity you want to model and manage. The relationships among them, the constraints you have among them. So these are the key things. And by doing so, of course, if you are the data expert, the domain expert, you should be able to tell by yourself, but normally sometimes you are designing database for somebody else, right? For your user, for your company, for whoever. Then in such a case, you need to talk to the data owner, okay? And in this example, as I said, I try to capture these already in English statements to explain what types of data we want to model in this small example and running example that we use for discussing. So we say that we want to model employee, department, project, and so on, and what types of detail. These will be the same thing you may need to do for your mini project as well. Once you brainstorm, okay, from today, we will have some time to talk about that. You need to work in your team and group, right? And then you need to come up with some idea of the things you are doing and define this requirements, data requirements, system, not system requirement, but basically the data requirements, okay, about your project. And the very first step before doing any design or anything else, okay? Okay, and this is supposed to be the resulting of the example, the design, the ER design, an easy one. Okay, so based on the given requirement for company database, this is some initial design, only entity plus attributes. The very first step when you make a design, data design, data model, you should come up with some idea of what are the main entities you want to maintain or collect the data, maintain the data for your data requirement, right? For your application and so on. So in this example of company database, we have employee data and employee entity comprising all these attributes. We think about from the given requirements, they say that we need to model departments, okay, and comprising all these attributes, we need to have projects. I think this is in the very first statement of the requirement, right? Maintain data about employee, departments, and projects. Also, dependent of employees for certain kind of benefit and welfare that the company wants to give to employees. Okay. And corresponding attributes are modeled. Keep in mind again about the notation. You need to strictly follow the standard notation of drawing ER diagram. So here, what do we have? We have employee and attributes like name, salary, sex, supervisor, address. We have department entity with attributes such as department name, department number, department manager, department locations. We have dependent such as dependent name, the dependent of employee. Dependent name, the employee that the dependent belongs to, the sex, the date of birth, the relationship of the dependent with regards to the employee. We have the project, modeling the project in the sense that keep project name, number, location, controlling department, and so on. Okay, so those are entities plus attributes, then the relationships. Each entity are not just independent like this, right? They do have relations among entities or between entities. And those are modeled and captured by ER model in the form of relationship. So usually in many cases, in most cases, we will see the relationships that associate two entities. And in that case, we call binary relationship. However, it can be ternary, it can be n-ary, multi-way, right? Many ways. And okay, what else I should say? There are some specific types of relationship, which is called a recursive relationship. That is, it is a relationship that relates to the same entity. The entity that has a relationship to itself. That is the meaning of recursive relationship. For example, here you can note the relationship notation, which is represented by a diamond in this chart notation. And mostly the relationship is given the name, which could be a verb. I mean, to make it readable. So finally, we will make our ER diagram readable. we need to make sure the readability of the ER diagram, because readability leads to understandability. We need to ensure these two things. When you draw any kind of diagram to model anything, right? Make sure those diagrams are readable and understandable to the users, to those who make use of it. Okay, so here to ensure readability and understandability in most cases, for sure your entity name must be a noun. A noun representing the things you are describing, right? For a relationship, it could be a verb or it could be a noun that describes the type of relationship in a very clear manner, easy to understand manner. Could be a noun, it depends, but try to make sure that it reflects the meaning of the relationship, okay? And when it is, this is an example of what I said, recursive relationship, right? So make sure that for recursive relationship, since it is a relation, it means that an employee relates to itself, you need to have, this is the role name. That for example here, employee involved in a relationship called supervisor or supervision, supervision with another employee. So the meaning is that there must be one employee having supervisor role, another employee in the relationship having supervising role. So if you draw a diagram, it should draw some kind of example. There should be a supervisee here. Okay, sorry, there must be a supervisor here first. Supervisor and supervisee, and both of them are employee, right? And they relate in the relationship which is called supervision. Okay. And when, okay, I should give you this diagram example first. As I mentioned, relationship is represented by a diamond in Shen notation. And there should be connecting line, right? In order to draw the, to define that this relationship relates which entity together. And it could be more than one entity. It could be 1, 2, 3, 4. So when in this example, okay, this is easy. Let's have a look at this one that I draw the red circle, the red line. We are saying that entity employee works for a department. So readability makes you to understand this easily, right? We can say that an employee works for a department, okay? And you may read the other example as well, that is an employee manages a department, or an employee works on a project, or even a department controls a project. So this is the power of making your diagram readable. It gives understandability by default. Okay, if your diagram is readable with clear meaning for your entity, clear meaning for all the attributes you model, clear meaning for the relationships you define. Okay. And what I need to emphasize here is about cardinality, or sometimes it is called multiplicity. It's the same thing. It's relation. It's about similar things. So it is used to define that how many times an entity can be related to another entity. How many other entities the relationship can take place. Okay, so let's have a look. I think it's easier to understand. It also used for describing whether the relationship is required relationship or optional relationship. Mandatory means required, right? For example, look at here. An employee, sorry. Okay, I want to focus on an employee and the works for relationship with the department. Meaning is clear. The cardinality represents here how many of the instance of employee entity could involve with how many of the department entity. For example, usually it is noted as here with the letter 1, N, and a few other kinds of letter. The meaning is, if you just read, we will say that one employee can work for exactly one department here. This is what we want to capture. So how do we make the modeling? It reflects. The very first thing, your modeling must reflect or must describe the business domain you are modeling or the application. Sometimes it is called application rules, business rule. Okay. So in my company, for example, this is for my company. I want to be very specific that each employee, the very first thing, every employee works for exactly one department. We don't allow an employee to work for no department. We don't allow an employee to work for multiple departments. But I define in my business rules, business logic, and so on that. Oops, sorry. Okay, that every employee must work for exactly one department. That means the minimum number and maximum number, if you want to denote it that way, that is easy in some cases as well. Sorry. Okay, now it should work. Minimum must be 1. Minimum cardinality is 1. Maximum cardinality is 1. For the employee, against, towards department. And on the other hand, in the reverse side, on the other opposite side, you could see here a department has how many employees working for it. If you read from the opposite direction, okay, a department can have many employees working for it with the letter M or N. Okay, it means many. So that is why if you recall some of the previous classes before you maybe your bachelor degree study of database, there is the cardinality of like one to one, one to many, or many to one, or many to many relationship that you want to model. And in this case, it is many to one relationship, saying that many employees can work for one department. Okay. And one employee can work for only one department. An employee work for only one department, and one department can have many employees working for it. So you need to read it both way like this, okay? And you define it. So this N represent many, one represent one. And the underlying not the underlying, sorry, the double line for the relationship means whether the relationship is mandatory or not. Mandatory or optional. When the relationship is mandatory, you need to make it double line. When the relationship is optional, it's single line. What does it mean? When the relationship is mandatory like this, okay, it means every employee must work for a department. So you cannot hire, that means you cannot hire an employee and your employee works for no department. Okay, that is mandatory. Here, another side, on the other side, I use a different color here in the green color. A department must have at least one employee. So department involved in employee relationship is also mandatory. You cannot have a department without any employee at all. That is another requirement. Okay. So let's see a different example. I focus again here on managers. We can see that there are double line and single line here. The rule that is captured and understood by this diagram, even I don't write it in English, but if you understand the notation, you will be able to understand it. It means that an employee manages a department. A department is managed by an employee. With the cardinality 1 and 1 here, mean that one employee can manage at most only one department. So if you are a manager of some departments, how many departments you can manage? Only one. You cannot be a manager of two. If you want to allow an employee to be a manager of any number of departments, then how can we change? Yeah, you change this to maybe N. Then the meanings change. That one employee can be managers of many departments. Okay, but in our case, we want only one. Okay. And then what else? Look at this. One department is managed by one employee. Meaning what? You cannot have two managers for one department, right? Okay. You are led by only one employee as a manager, but for one particular department. And then this is optional. And this is mandatory. Meaning what? When this line is single, right, it means optional. Meaning that there might be some employee who does not involve in managing any department. Meaning not every employee is a manager, right? You cannot give a management position to everyone, right? Some employee doesn't manage anything, just ordinary employee. So this is optional. Employee is optional to participate in this managers. But on this side, this is mandatory, meaning what? A department every department must involve in this managers relationship, meaning every department must have a manager. Otherwise, there is no one taking care of the department. So all these things reflect the, as I said, data requirements, business logic, and so on. So different company may have different rules, of course, and that will be reflected by different ER model. Right? If you are modeling company if you are drawing or modeling ER model for different types of companies, you may result in different ER models. Okay. And the same for employee and workforce works on the project. Let's look at this. We can see here what this line, these are double line, right? Mean that, and these are also the mandatory. No, these are also the M and N. So we are saying that employee can work on many projects, and a project can have many employees working on it, right? Yeah, with the M and N. And with the mandatory means at least you need to involve in some projects. You cannot just be employed and no projects to work on. And at least every project you must assign some employees to be project members, right, in that project. Okay. Yeah, there's no strict rule. It's fine to use only any time M or N interchangeably. No fixed rule. No strict rules. You can even use just M or N or both of them interchangeably. It doesn't matter. So basically M or N, it reflects many. So it reflects many or any number. It could be from 0 to any number. Okay. And 1 means just, actually 1 could mean 0 or 1. When it is 1, it doesn't always mean exactly 1, right? It will be exactly 1 only when you use it together with the mandatory symbol notation, I mean. Okay. Yes.
So on the diagram, an employee must work for at least 2 projects.
At least a project. One project. And here can mean many or any number. So actually when it means many, it means it can be more than 1, but 1 is fine. So it more or less talk about the maximum. So actually the cardinality talks about the maximum. Such as 1 here means the maximum. It can be 0 or 1. So M or N means 0 to M. Okay. Weak entity. This is what I will come back. Okay. We talk about that later on, but basically we will look at the whole picture first. Okay. So this can be the overall diagram describing the whole company database for our example. So we have employee, work for departments, employee manages departments control projects, and employee have supervision relationship together with the employee entity itself. Okay, example of recursive relationship. Employee works on projects, and employee have dependents, or there are dependents who are dependents of certain employees. And actually, the thing that I would like to emphasize here, of course, the first thing, when we make a day, it's the same with any other kind of designs, right? When you are making certain design, either database design, application system design, and so on, usually you will not get the right or the best perfect design in one time, right? You will go through several rounds of the modeling of the design. You will need to go through certain kind of refining, right? Making your design better. You need to do also the verifying of your design among the team, among or with the users, with the project manager, with whoever, right? Involved or stakeholders. Okay. And finally, of course, even your final design, it will be final for a certain period of time anyway, right? If you talk about change in terms of requirement and usage, finally, your final design will never be final for forever. Okay, it is the final design for certain time, but at least it's final design for you to move on to the next phase and perhaps require certain kind of design maintenance, design revision, and so on. So this example that is shown here, of course, has been, if you go back and have a look in these slides, you will see that there have been certain kind of evolution, okay, more or less. For example, something like the very first version, if you try to map correctly, okay, here, even here, the very first design in this example, we have that employee has an attribute works on, and this works on include project and hour attributes as kind of a composite attributes. Okay. This wants to capture that each employee may be working on several projects for several hours, for certain hours, right? And then it reflects on using this double oval for the multi-value and also make it composite attribute and so on. So this is kind of initial idea, initial model. But if you compare, okay, on this example, here the work on has been revised from the first modeling that used attributes, multi-value attributes and composite attributes to become project entity and relate this project entity with the employee through a certain relationship instead. So the very initial design sometimes just to capture the understanding, and then you need to go through, as I said, refinement process, right? Make them better, make them more accurate, make them a better modeling result. So that is here. Small note, okay. This dotted notation means derived attributes. So it is an attribute whose value can be computed by calculating by certain ways and obtain the value from other attributes or other computation. So that means even you don't store the value explicitly, there will be ways for you to calculate it. But sometimes we may want to explicitly store the value for easy calculation, fast retrieval, and many things, right? Many reasons to do the same, to do it. So, for example, here the department has attribute number of employees. Even you don't count it explicitly and store in these attributes, there are ways that you can aggregate and count number of employees working for the department, right? And store it. And what else? Underlying, of course, means the values is unique. So here, department number is unique. No duplicate value for department number. Here again, department name is also unique, means that it is the control within your own company, right? You may not want to name two different departments with the same name. Who do that, right? Also, project name, project number, they are both unique. Employee SSN is a unique value. And okay, then I can go back to the weak entity later on. Okay, let's summarize here first. These are all the model notation summary, okay? And keep in mind again, as I said, it refers to the notation quotient notation. If you look at a Crowfoot notation, okay, I have example of Crowfoot here. This is Crowfoot notation, very similar to what you have seen in Workbench. Okay, and actually, if many of you are familiar with UML class diagram, it also has certain similarity, but not exactly the same. The way that is similar, okay, I introduce a little bit so that you can see the relationship and you can actually convert one notation to another easily. Entity name. Attributes are listed inside the box. So it's kind of the rectangle with two parts, right? The top of the rectangle represents the entity name. Then the remaining part of the rectangle, you list the attributes. And for certain, maybe certain symbol like asterisk is used to denote the identification or uniqueness. Okay. And there are certain notation for the multiplicity and cardinality. This means many. The reason it is called Crowfoot because of this, right? It looks like Crowfoot. So this means many, this means one. And actually, there are quite a number. This is optional. This last one means mandatory. So single line, there are many lines, so you need to pay attention a little bit. This is optional, many. This is mandatory and one. This is also mandatory and one. Optional and many, and so on. And so whenever it is circle, it means optional. Whenever it is a straight line, vertical line, it is mandatory. And one is a straight vertical line as well, where the Crowfoot itself with the 3 dash here, it is for many. And what else? Okay, those are examples. Please have a look by yourself. They are simple, easy. Okay. Other notations, as already mentioned, you can also have UML. You can also use UML class diagram to represent similar relationships among the data. Okay. And for UML, you may see that it makes, instead of using the crowfoot, the circle, the dash line, vertical line, and so on, right? It makes use just the number. So this make it very explicit for the minimum and maximum cardinality. And okay, I think I should go back to this one more time. Okay, this is also alternative notation. Instead of using double line and then one and many, as similar to the UML, you can use min and max notation to easily make it explicit as well. Okay. So this one together with this one, they are actually the same, but just different on this way of representing the min and max, mandatory and optional, and cardinality stuff. But they are the same. So look here, okay, as I said. And with this, you can have a choice of making a very specific cardinality to represent certain value, such as an employee can work for minimum 1 department and maximum 1 department. Okay, this is clear. A department in this example, okay, this is just for the purpose of giving example. A department can have minimum 4 employees, maximum any number. So with this, you can even explicitly define the minimum value or maximum value with specific number. You can replace n with 100, for example. You don't want to grow your department to the size over 100. So you say minimum 4, maximum 100, like that. Okay. Then I can come back to this. Weak entity. Weak entity is the case when you want to represent. It's similar to entity, to regular entity, but you only want to use weak entity when the entity itself, the existence of the entity itself rely on the existence of another entity. For example, here, when we have the dependent, okay, dependent entity here is considered weak because actually you will model this dependent, record data about dependent only when you have the employee, right? Dependent belongs to just the existence of employee. You don't record any dependent in your company database. So it is considered weak because we don't, it also doesn't have key or unique key value by itself to identify the entity as well. But the major thing in most cases, sometimes I need to I make it bigger. Oops. I call it owner. Okay. Usually, a weak entity must have what we call identifying entity, so that it relies on that identifying entity for the entity to exist in the database system, in the application. So for example, if we look at this dependent, logically, okay, we need to understand the concept first. Concept of dependence in this example is that it stores data of those dependents of employee. Employee may have kids, children, for example, or anybody who are depending on the employee, right? And the company would like to give certain kind of benefit. So what we want to model here in this database system is that we include the name of the dependent, we include the sex of the dependent, the date of birth, the relationship of the dependent. The reason we use this dash as an underlying for the name, because name alone for the dependent is not unique. It's not a unique key or doesn't give any identification purpose at all. Cannot be used to identify the dependent. Names may duplicate because we may end up having dependent names with the same values, right? But we can make name or we can uniquely identify a particular dependent when we refer to the, we call identifying entity or the owner entity. So if suppose we have employee John with the SSN number 1 and his name is John. Okay, John may have dependents who are Jack and maybe Jim. Okay, John has 2 dependents. So we know we will identify Jack and Jim by using the name of the dependent together with the ID or identifier of the owner entity. That is the way. So it's kind of relationship back to the identifying entity. The reason we say that dependent cannot have its own unique value because some other employee may somehow have dependent with the name Jim and Jack as well. That can be perhaps happen, right? And in ER model, later on when we convert ER to relational schema, it may happen that you may simply create what we call surrogate key, surrogate ID, and so on. So you just create any auto number to be a key, right? Then it's solved. Everything will be unique in that table. But since ER model usually reflects the world, the real world that you are modeling, when dependent never have ID, any newborn child, person will not be born with some form of ID, perhaps, okay, depending on which countries we are talking about. If we are talking about Asia and Thailand, I think when I was born, right? I have my ID together with myself, and I use that forever. But anyway, so dependent may not have any specific ID. So if we use name alone, it will not be unique. But name together with the SSN of the identifying entity will make it unique, possible. Okay. So we model weak entity just for this purpose, and notation for weak entity is by making double rectangle notation. And since a weak entity may have relationship with many other entities in the way it's fine, it could be that dependent have some relationship with something else, such as attending some school. We want to record that which school the dependent goes to. That is fine, right? So you can have like this. But then the relationship that relates the weak entity to the owner entity is to be noted, represented by double diamond as well. So this means in order to define that which entity is the owner entity of this weak entity, you just follow the double diamond, then you will find the owner entity. Because if I have dependent in this direction, dependent attend school, then you may not know that if there are more than one relationship that the weak entity relates with, right? Which one relate to the owner entity? So in order to know this, it must be the identifying entity like this, okay, that you use. So let me make it cleaner. Okay, so with this, we are saying that dependent having relationship dependence of relate to employee. It tells us that this is the owner entity of this weak entity. Okay. And I think that's all for the most important thing related to ER model. Okay. The very next set of slides in which I want you to go through by yourself first, we find a chance to wrap and discuss them quickly. Part is this one. Okay. This slide, relational database design using ER to relational mapping. Remember, okay, this is the obtain entity relationship design, right? For the company database. And what I want to emphasize, remember, we have data requirement, collection, understanding, analysis, so on, right? Then we are doing conceptual model. This is the conceptual model, the ER diagram that we obtain after we understand the data requirements. Then the next step is to make a logical design, right? Conceptual design, conceptual model, the same thing. To make a logical design, it means you have to choose which database technology that you want to use. And then make a schema using that technology, right? So it means here that if we choose relational database technology to be the one you want to use to model your data requirements database system, then the schema you are making is relational schema. But if the choice is different, that is, we want to choose document model, for example, okay, document model as the database technology, we will make document model schema instead. But now we are on this topic to learn relational model and relational schema, right? So we will make this. So this is the result. This is A. Okay. And suppose this is B. So this is the result of this logical design phase. Okay. Meaning that we are following here. How can we make database design? You from ER diagram in by based on what we call relational mapping. So there are 7 steps. Okay. Step 1, do what? Step 2, do what? Then you will obtain the table schema from this. From this, you will obtain this as table schema, which is what? You will have table employee with all these attributes. You will have table department with all these attributes. And this is the primary key of employee. This is the primary key of department, where all these links relational. This is called relational schema diagram. Okay. What you see here is called relational schema diagram. All these links are foreign key, right? So we say that, for example, D number, Dino, is a foreign key referencing to the department table, and so on. Okay. Actually, if you do this, it means that you can, from this relational schema diagram, you can create a relational database, right? In your MySQL, for example, or whatever relational database system you want to use, right? That's the thing. Okay, I think that is what I want you to make sure that you understand all these 7-step algorithm for converting from conceptual design to the relational schema in the logical design. Okay, and that is it.